I've been part of the Hedera ecosystem formally for 3 years now, and then I've been playing with the SDKs and following from the sidelines for 4.5 years, just about. And in terms of professional interests, blockchain and the overlap of blockchain with other technologies is also something I find very interesting, specifically the intersection with AI, where I see a lot of promise, and I've developed a few plugins and fun utilities here and there. So we only have 20 minutes, and I want this to be hands-on, so I want to go through these slides fairly quickly. And my goal today is to let you know what is Hedera, why build on it, and then how you can get started doing that. So starting with what is Hedera, Hedera is a open source EVM compatible layer 1 network. I'll leave it there. So that's pretty a set of familiar concepts for this audience. And so when you think about what makes Hedera different, I like to think of it in two buckets. One bucket is technology, the other one is governance. So when we think about technology, Hedera has a next generation consensus algorithm that makes it truly scalable, it makes it fast, and makes it very secure. And so I mentioned in the previous slide that Hedera is EVM compatible, and it uses the Hyperledger Besu EVM client as that execution layer for smart contracts. Now, a key differentiator there, it's not only it has performant, fast, cheap, scalable smart contracts, it also has things beyond the EVM, beyond smart contracts. So we have other services that I'll tell you about for tokenizing, for creating timestamps and records, and you can access those services via SDKs in languages like Java, JavaScript, Go, Swift, C++, and Rust. So whether you're coming from the Web 2 world or the Web 3 world, there is an easy entry path for you with Hedera. And then because of that technology and that next generation consensus algorithm, there are other benefits like consensus without leader nodes and also fair ordering. So there's no window for MEV on Hedera. And some people say, oh, MEV is a feature, but it's a feature until it happens to you. And so here you have fair ordering, which is important for various use cases. When we think about governance, it is a global council of organizations doing the governance decisions, driving the operations, and also building use cases on the network, where we have names like Google, IBM, Ubisoft, LG, and many more. But it's not only for enterprises. There's also a lot of Web3 projects and a small community of Web3 ecosystems being built on Hedera. The other differentiator is sustainability. So is the greenest energy or greenest network in terms of energy consumption in the market. And this is a study done by UCL or University College London that shows the energy consumption per transaction of Hedera. And what you can see here is that with the same energy that it takes to do one Visa transaction, you can do about 1,000 Hedera transactions. So really a massive improvement in the order of magnitude that represents. Now, when we think about why build on Hedera, so I mentioned a few things about technology, governance, but there's also a very active community of projects, startups, and founders. And we're also seeing a lot of active developers joining us in global events, hackathons, meetups, being active on the network. We have over 100 applications deployed on mainnet, and to date, we've processed over 70 billion transactions on mainnet. And so that is by far the highest number that I know of any public networks in terms of transactions. And then we've also seen very healthy growth in terms of accounts in total and also year to date with millions of accounts just being created this year. Another reason is because we have great hackathons, great incentives for you to get familiar with the network and start building things so you can ultimately deploy on mainnet and serve customers. So here we have at ETH San Francisco, we have $10,000 worth of bounties, with bounties for EVM starters, for people just getting started with our native services, and then for more advanced developers where they can build something compelling and walk away with $4,000. So happy to tell you more about those in our booth. And then we also have a big hackathon coming up in about a month. So it opens on November 11th. You can register now, and that one has a total prize pool of $300,000 for those winning projects. So you can learn about that one at hedera.com/hackathon. So let's start building on Hedera. And what we're going to do is we're going to review the services real quick. So the services that I mentioned before, we have smart contracts, which you can see all the way to the right. We have a tokenization service that allows you to create tokens even without Solidity, just using Java, JavaScript, Go, and those other languages. You can create fungible and non-fungible tokens, which is very attractive for those folks coming from Web 2 world. And we also have a consensus service for creating decentralized records, logs. And so you can think of this as a decentralized messaging bus that allows you to have topics and also messages within those topics. And this is the part of the tech stack that is governed by the Hedera Council. And then on top of that foundation is where developers like yourselves build compelling use cases and applications that serve end users. So with all of that context in mind, let's jump in and open up this repository to choose your own adventure on how to create a token on Hedera. So here, I'll leave this URL just for one more second, or if you want to copy the tiny URL, feel free to go ahead and do that. All right, so now, all you need for this workshop to follow along is a browser and a GitHub account. Hopefully most of us already have a GitHub account. And so what we'll do here, if you go to that repo linked in the slides, is you can open it on Gitpod, which will automate any setup that we have to do. And so now that we're here, what you're going to see is that this is going to open 3 different terminals. So these first 2 are just running processes in the background, and then this is the main one that we're going to use to follow along in our tutorial. So what we're going to do is we're going to create or deploy an ERC token on Hedera, and then we're going to deploy a native token on Hedera just to show you those 2 paths that you have to tokenize on this network. So we'll start by generating a seed phrase. This is going to be a BIP39 seed phrase. And we're just going to do that with the default values. So we can just hit enter here. Next, we're going to, let me zoom in a little more. From that seed phrase, we're going to generate accounts, Hedera accounts. And so the default value will be 3. We'll proceed with that. And then we're also going to instantiate a JSON RPC URL endpoint to be able to submit transactions to our network. If you're going through a JSON RPC, that means you're probably working on smart contracts. And then those other native services like the token service, the consensus service, those can be accessed directly via the SDKs. In this case, we'll proceed with this JSON RPC URL value. And next, we want to enter a private key or generate a private key. In this case, we'll also generate one at random by using the default value. Just hit enter there. And now what we have to do is we want to fund this account. So we're going to fund this account by going to the Hedera faucet. So if we do faucet.portal.hedera or portal.hedera.com/faucet, we'll just give it a second here. Now we can enter our EVM address, and just like that, we can receive 100 HBAR to start our development and our testing. So there you see that from that EVM address, we were able to create and fund an account. And so now that that account is funded, we can proceed here. And what you'll see is that it's also creating a few additional accounts. So those values that you see in the terminal there, they're now going to be written to our .env value if we say yes, so that we have those variables on disk, right? And now we can start working with all these things. And what you see here is that our JSON RPC is actually instantiated, it's live, and we can probably start deploying our ERC token or ERC contract on Hedera. So what we're going to do is we're going to use the files in this folder. So token HSCS, that stands for Hedera Smart Contract Service. So we'll just do a good old CD. And there you see we have a few files. We can show them here as well. But what you have is a script that we will use to walk through the deployment and interactions step by step. So we'll do /script. And so that's going to walk us through all the steps that we need to run through. So here we can see the lines of code that will be running up to a certain point once we hit enter. And the first thing that we're going to do is we're going to check the Solidity that we're going to deploy. The Solidity contract that we're deploying in this case is a very basic implementation of an ERC20 token. So just the bare minimum that you need to be able to deploy that. So let's go ahead and run that. Next, we need to load up the EVM bytecode and also the ABI of our contract. So there's the code that points you to us doing that. In this case, we haven't done the compilation, so it's going to error out, which you'll see here. That's expected. And so obviously what we need to do is now compile that smart contract into bytecode and also generate the ABI so that we have the summary of the different functions that we have in that Solidity file. So we're going to do that with npm run. And there you see the different options that we have. So the one that we want is this compile smart contracts, because that's going to basically execute a source.cjs compilation that gives us the ABI and the binary for the my token contract. So let's go npm run compile smart contract. There we go. Now you see that we have a bunch of artifacts here, binaries and interfaces. And so now we can come back to our script and try to rerun that once more. So yeah, we're checking. Let's proceed. Let's load. And you see that we were able to get the constructor, the ABI string, and here's the important piece, the different functions that we'll have. In this case, the function that we're going to use later on is going to be this transfer function in our smart contract. All right, so now let's check that our JSON RPC is live. We're going to check that with two endpoints here, so get block number and get balance. So we're just calling that, and indeed it is live. So now we can submit our EVM transaction to deploy the bytecode of our contract. So we're going to do that right here. We're using the deploy contract. In fact, I forgot to mention that in this file, we're using VM for the deployment and the interactions with the contract. So we use this deploy contract. Here we're passing the ABI, the bytecode, and some arguments for the constructor, which is just the token symbol and the token name that are being passed right here. So let's go ahead and proceed with that deployment. And then this transaction typically is one of the heftier ones on Hedera. It's probably going to take a little bit more than 3 seconds. That's typically the time to finality that we're working with right now. And once this completes, you're going to see the different links for the successful deployment of the contract. So we can go to Hashcan, which is a transaction, or the Network Explorer. We can see the details for the deployment transaction. There we see it's a contract create, Ethereum transaction type, and a few more details. And then if we come back here, we can also look at the URL for the contract that just was deployed. So instead of a transaction, we're looking at a network entity. So here's the contract, the details. And right now we see all the bytecode and all the assembly bytecode as well, and a few more sets of information like events, but it's not readable. It's not human readable. So the next step that we want to do is that we want to verify that smart contract so that we can have more visibility into the source code, the ABI, and the events that are part of that smart contract. And so I already ran that here, but what you'll see is that Hashcan, the Network Explorer, has an instance of Sourceify that allows us to do that smart contract verification. So now if we go back to our contract and we refresh here, you can see that the contract has been verified programmatically with a full match. And so now we have a few more tabs, not just the bytecode. We have the actual source code and the ABI. And one thing that I didn't mention is in the verification process, what was passed is the source code, right, the solidity code, and also the metadata that was an output from the compilation process. So that verification just makes this Explorer more usable, and then you can even interact with functions in your contract right there. And so now we're going to submit a transaction to basically write a value and change the state of that smart contract. And so what we're going to do is a transfer. So we're using this object, or the client object, write contract. We pass the deployment address that we want to call, the ABI, the function that we're going to use, and then the parameters for that function. So the receiver and also the amount of tokens that we're sending. So let's proceed with that. There it is. So the transaction has been successful. We see the status. We see the URL also on hash scan over here. And we can see information here about this specific transaction. So the input, which was the receiver, the amount of tokens that we transferred, and the output, which is true, which indicates the transaction went through. And there's more details about the call trace, the contract state, the events, and so on. All right, so now that we've submitted a transaction, we're going to submit a query. So we're going to read from that smart contract, right? So this is not really a transaction. It's more of a read query since it doesn't really affect the state. So we use read contract for that. We point it to our deployed address. We provide the ABI, the function name, which is balance off. And then we're going to do the address of the account that we want to query the balance for. So we proceed with that. And then we see it right there that it's 100 token units. So the other part that I wanted to show you, so again, we just covered deployment, interactions with, and verification of a smart contract. That was an ERC20. The other part that I would like to show, which I don't think we're going to get through this one because of time, is creating a token directly without even deploying a smart contract. And this is what we call a native entity that lives on Hedera because of that smart contract, or sorry, because of that Hedera token service that I mentioned before. So you see, it's just an import from the SDK package. And then the deployment happens very easily using this token create transaction, setting the properties for the token. And then we walk through the process of associating an account with that token and then transferring that token. But this is code that you can all inspect, that you can try out very easily. And then hopefully it will be helpful for the hackathon portion of this event. So I'll stop there and then see if there are any questions, or if not, we can close and move on. Fantastic. Thank you all very much for tuning in and for joining live.